So you guys know how to write equations of exponential function or linear functions with y equals mx plus b. We've also learned how to write it in point, slope, and standard form. There's only one form we're going to be writing equations of exponentials in. So we are going to make sure I can write the equation in the form y equals ab to the x, because that's what an exponential looks like. So if you see anything that looks like y equals ab to the x, you know it's exponential. And we're only going to do it from a table or a graph. And you can determine whether a contextual situation would best be modeled by growth or decay and write the equation. These ones are going to be simple ones. When you guys get back Monday after break, we are going to do ones that have formulas. We will give you those formulas on your test. There are also formulas the EOC gives you, okay? But the formula day is a little bit different than what we're doing today. All right, so this is the exponential equation. F of x equals ab to the x, where a is the initial amount or your starting value. This is typically your y-intercept if your asymptote is 0. So it's your y-intercept if your asymptote is 0. B is your growth or decay factor. It's what you multiply by each time. Remember, division needs to be changed to multiplication. Remember, division must be changed to multiplication by multiplying by the reciprocal. And then x is the period of growth or decay, and it's typically time. So x and f of x will not have a number to substitute in for. So it will not be numbers. They will stay in the problem. Just like y and x stay in the problem in y equals mx plus b. So look at that and see what questions you guys might have for me already. But if you do not have any, please flip to the next page so I know you're ready. All right, so let's start from a table. So we're going to write the equation for each table. And we'll talk about how to find those growth or decay factors. Sometimes, bless you, you can do it just by looking at it. Other times you're going to want to know another method just in case you can't because it's a decimal. But let's first start here. Is this function here exponential? In example 1, do you think it's exponential, and explain why? So Katie, what do you think?
I think it's exponential because it's multiplying by 1/3.
So it looks like it's multiplying by 1/3 each time, right? And I'll show you a way to check that if you're not 100% sure in just a second here. So Katie, is that growth or decay if you're multiplying by 1/3? So it's decay because your factor, as Katie said, is 1/3, right? which is between 0 and 1. So if you're between 0 and 1, it's decay. If it's greater than 1, it's growth. So say that you can't tell by looking at this that it's dividing by 3. The reciprocal of dividing by 3 is multiplying by 1/3. Say you can't see that just by looking at this table. What you can do is you can take the bottom number, divide it by the top, and you can get your growth factor. So if I look at this one here, so what I did here is I took this divided by that, so you're going backwards, and it gives you your factor. So even if I would have done it with the other one, so if I would have done it with, so this is with 4 and 3, right? So if I would have done it with 3 and 2, I would have gotten 3 over 9. What does 3 over 9 simplify to? So if you cannot see it, all you have to do is take the lowest number divided by the number right above it, and it will tell you your factor. Those numbers probably don't make a huge amount of sense. I've been trying to think of a way to explain it by putting words to it, but I just don't know that I can necessarily do that. Does that make sense to you guys, what I just did there? Anybody confused by that? So, yeah.
So, like, on the next table, you would do 180.
Well, start at the bottom number. So start at 3. So you'd start with 32, and what would you divide 32 by? 8, which is what? What's 32 divided by 8? Somebody help Jenny out. It's 4. Yeah. So does it look like everything's being multiplied by 4 there? Like when you go back and check it? So that's how you could do it if you can't see it from the table. So what is our initial value? So remember, the A value is your y-intercept, and your y-intercept is when x is 0. So your y-intercept is when x equals 0. What is your y-intercept in this one here? Alex, what's my y-intercept? 81. So now we just go about writing our equation. Our equation is y equals ab to the x power. So Morgan, plug into that there and give me the equation. Perfect. So it's not too bad, is it? Now, like I said, it can be more challenging depending on what your y values are, because if you have some decimals and fractions going on here, it can be harder to see. So just remember that you take the lowest divided by the next above it to get your growth factor if that ever happens. Or decay factor, I guess, in this case. So we've already kind of talked about this. And we said that if you do 32 divided by 8, so this is the third and this is the second, we get 4. Does it look like on this table we are multiplying by 4 each time? Half of 4 is 2. 2 times 4 is 8. 8 times 4 is 32. So that does make sense there. So is this exponential or not then, Jacqueline? Yeah, it's multiplying. If it wasn't multiplying, then we would not have an exponential. So this is a really important piece for you guys to realize as we approach the end of the semester and going into second semester. When we get to the EOC, there are going to be tables on there, and it's going to ask you if it's linear, exponential, quadratic, or neither. Typically is what it asks. You'll learn quadratic second semester. Quadratics and exponentials can look like each other a little bit if you only see half of the parabola, which you'll learn. You have to look and make sure for an exponential that it is multiplying by the same thing each time to get to the next term. If it is not doing that, it is not exponential. So just because it kind of looks that way on a graph, make sure that you are actually multiplying the y values by the same thing. All right? That's the really big piece of that. So we did say it was exponential because it's multiplying by the same thing each time. So Jacqueline, is that growth or decay? It's growth because your factor is 4, which is greater than 1. You're confused, Hannah?
Yeah.
What are you confused about?
So the first one, it was like you multiplied by 3, but then why did you start?
You divide it by 3 each time. 81 divided by 3 is 27.
Okay, so then first one you multiplied by 4, so then the factor
Right. The only reason it's 1/3 for the first one is because we can't think about it as division. We have to think multiplication. So you can think about it as division to start off with and then change it to multiplying by the reciprocal. So if you think about it as dividing by 3, that's the same thing as multiplying by 1/3. Okay, does that make sense?
Yes.
Okay. So what is my initial value, Jenny? What is my a value, my y-intercept, when x equals 0? So x is 0 here, so that's how we got that. And this one, x was 0 here, so that's how we got that one. So Spencer, I'm going to call it f of x this time. F of x equals ab to the x. Tell me my exponential for this one then. F of x equals what? Exponent of? What's the exponent? There needs to be an exponent up here. What? X. There you go. It's not exponential unless that variable is your exponent. So before we move on to the next one, do you guys have any questions for me? Okay, we'll move on to the next slide here. So there's some decimals in this, there's some big numbers in this, and this is why I'm saying it's important that you know to divide the bottom one by the top one when it gets to these examples. So you might be able to see it, you might not. But what you could do is take the last one and divide it by the one right above it. So if you take 0.064 and divide it by 0.32, it could tell you what you're doing. That's because you're working backwards. So this is why this works. So the inverse of multiplication is division, right? So if we move forward, we're always thinking multiplication when we move forward, right? So when we move backwards, to invert multiplication, you need to use division. So that's why that works the way it does. So go ahead and do 0.064 divided by 0.32 in your calculators. And what do you get? Okay, so what we're going to do here is just check that that is actually true. So do 8 times 0.2 in your calculator. Do 8 times 0.2 in your calculator and see if it gives you 1.64. Did that give you 1.64? Okay, now do 1.64 times 0.2. Does that give you 0.32? So you need to go back and check to make sure it's actually working after you've done that. Because if it's not multiplying by the same thing over and over again, then you're off a little bit. So what questions do you guys have about finding that growth factor or decay factor in a situation that's a little bit more difficult than maybe that first slide? Kelly?
Would you rather it be the fraction or decimal?
If it starts as a decimal in the chart, you can use it as a decimal.
Okay.
Typically, I would say as a fraction, but like this one has context to it. So in a context situation, you're also allowed to use decimals.
Okay.
So context situations, or if it starts as a decimal, you can keep it as a decimal. Does that make sense?
Mm-hmm.
All right. Mackenzie, is this an actual exponential function?
Yes.
Yes, we are multiplying by the same number over and over and over again. So Iris, is this one growth or decay? Decay. 0.2 is between 0 and 1, which makes it decay. You can also see it from the chart. Yeah.
You circled growth.
I did circle growth. Thank you. I said decay and circled growth. You can also see it from the chart. Isn't it getting smaller and smaller in the chart? So if you know it's exponential already and you look at the chart and they're getting bigger, it's growth. And if it's getting smaller, it's decay. Or you can look at the growth factor or decay factor. Sarah, what's my initial value in this one?
200.
Do we have when x is 0 in this one? So we're going to have to work backwards here. How could we work backwards? What are we going to have to do to work backwards? What are we going to do?
You gotta divide 8 by 0.
What is 8 divided by 0.2?
44.
Okay, and then did we find our y-intercept yet? No, so we have to do 40 divided by 0.2. What's 40 divided by 0.2? Good job. So you were right, Sarah. But we do need to understand how to do it. So if you need to work backwards, you must use division, because the inverse of multiplication is division. So that's how that happens. All right, what is my equation, Madison? Good. We always plug into y equals ab to the x. All right, the next one is a population growth over time. So this one here is in a context situation. In context, you can use your growth factor or decay factor as a decimal. You're probably going to get a decimal, so round to 2 decimal places for me when we do this. So we're going to start at 1978 and divide it by 1977, but we're going to use those numbers. So 3,490 over 2,167. What do you guys get when you do that? What'd you say? Is that a whole, actually, did you have to round it or no? You did have to round 1.61? Okay, so let's just make sure that works. Do 200 times 1.61 for me.
200 times what?
1.61, because that's what we got our growth factor as. Did it give you 322-ish?
Yeah, 322. Exactly.
Perfect. Okay, then do 1.61 again times 322. And what do you get? 518.42, or what is it? So it's close to it. It's not going to be exact because it is a population, but it looks like it's close enough to keeping that pattern. In this case, because in context, things can be exponential because they're close to being exponential. They won't be as perfect as a non-context situation. So, Alex, is this function exponential? Are you saying that because we're not getting the exact numbers?
Yeah.
Remember, we had to round that decimal, so that's probably why we're not getting the exact numbers. Yeah. If we didn't round that decimal, I'm sure if you would have kept that decimal in there and multiplied it each time, it probably would have been more exact. So we'll say yes there. And Alex, is that growth or decay this time? Growth. The population is getting bigger and bigger over time. You can see that in the chart. Also, 1.61 is greater than 1. Okay, we're going to say that 1972 is 0. So we're going to say 1972 is 0. So we're going to say the initial value is when 1972 is 0. So we're going to say years since 1972 if we are ever talking about this. So the year 1972 is our 0 here. So how many people were there in 1972? 200. Yeah.
But the equation doesn't matter if you do y or f of x?
No, I mean, if it says to write in function notation, you have to use f of x, g of x, any of those ones. But if you're just writing an equation, it's fine. Let's use g of x this time just to mix it up a little bit here. So g of x equals... Carly, what does g of x equal? Good. All right. So what questions do you guys have on writing equations from tables? Do you guys understand how to work the growth factor in like trickier situations like example 3 and 4 were? Does everybody understand what I was doing there? How about questions on if 0 is not in your table? Do you guys understand how we got to 200 here? So the inverse of multiplication is division. So to go forward, we use multiplication. To go backwards, we use division. Yes?
In problems like example 4, so should we just always assume the first one is 0?
You can just let the first one be 0. And then if you were asked questions later about it, you would say, since, this is since 1972. So it's years since 1972. Okay, use the graphs to answer the questions. And then we're going to write the equations for both models. All right, find the growth factor for the two species and which species is growing faster. So we need to find the growth factors for each. So we have species X
Species Y.
and species Y, yes. So how could I find the growth factor from a graph, guys? What could I do? Yeah.
Do
Use points. Yeah, couldn't we take some points off and put them in a table? And they already gave us points on there, for this one at least, because they're not...
Species Y.
Okay, but we first have to do the growth factors. We're not on the second question yet. So, looking at this here, what is our growth factor for species X? Katie, what did you say? So if I do 135 divided by 45, that's 3. 45 divided by 15, that's 3. 15 divided by 3, or 5 is 3. Does it look like they're all multiplying by 3? So if you have a graph, you need to take some points off the table, or off the graph and put them in a table. If you have 3 points and just take 3 points, that's completely fine. So as long as you have 3 points in your table, that's completely fine. But we can see that the growth factor, our B value, is 3. So it tells us it's 0.25. What is 1 at? What is 1 at? 50. So you just follow it up and over. 2 is at? Okay, so what is it being multiplied by each time? We have a multiplication of 2. 100 divided by 50 is 2. 50 divided by 25 is 2. They're all being multiplied by 2. So our B value is 2. So is species X or species Y growing faster? Why are we getting that? Mackenzie, you said species X?
Yeah.
And why?
Because the B value is greater.
Yeah, so species X, because 3 is greater than 2, right? The growth factor is greater. So species X is going to grow, whatever this population is, the species is going to grow quicker in X than it is in Y, because it's being tripled, and species Y is only being doubled. Alex, what's the y-intercept for species X?
5.
Say it as an ordered pair.
0.
And what does that mean in context of the problem?
That's how much is.
So use the units as we've been discussing for the past week or so. You're right that it's a starting amount, and use the numbers in units. So use the number 0 and use the number 5. Yeah, at 0 years you have a population of 5, or the beginning amount has a population of 5, or the initial amount has a population of 5. Any of those work. So at 0 years, there is a population of 5. Kelly, what's the ordered pair for species Y for the y-intercept?
Y equals.
I want an order.
The species. Oh.
Species Y's ordered pair for the y.
0 to 25.
Good. And what does 0.25 mean?
Add 0 so it'll be 25. The population will be 25.
At 0 years, the population will be 25. Hannah, what's my equation for species X?
Y equals 5 in parentheses 3 of X.
Y equals the y-intercept of 5, our growth factor of 3 to the x power. Very good. Spencer, what's the equation for species Y? Be careful. 2 isn't right. A is the first number is your y-intercept, yeah. So y equals
25
good. Times what?
times
Good. That's your growth or decay factor.
X.
Good. Sorry, that's really scrunched in there, guys. So it says, for which equation is 5, 1,215 a solution? So I see some of you taking your calculators out. Madison, what are you doing? To figure it out. What are you going to do to figure it out? For the x, if you plug in 5 for x, for both of them, you can see which one gives you 1215 as its answer. So go ahead and plug in 5 for both of them and see which one gives you an output of 1,215. Does anybody not know how to plug it in their calculator and need my help? So I got it for x. I don't even have to plug it in for y, do I? No, so species x is your answers. So questions there. Questions there. Do you guys have questions on how to write the equations from graphs?
No.
Are we doing okay so far?
Yep.
This is the last thing that you need to know for your quiz. So it's not like you guys have anything else after this. Your quiz will be Tuesday. We'll review on Monday. So let's do some of these word problems. Answer each word problem by first writing the correct exponential growth or decay function. So Fido did not have fleas when his owners took him to the kennel. When he returned from the shelter, he had 8 fleas. Each day, the number of fleas tripled. Write the function to model this situation. So first, let's determine our A value. What is our starting amount of fleas he had? 8. We can't use 0, else it's going to cross it off. We're saying when he returned from the shelter, he had 8 fleas. So what's happening after that? I understand why you said 0, because he didn't have any when he got there. So we're saying when his owner picked him up, he had 8 fleas. All right? What is our growth or decay factor in this case? Jenny? 3, because it tripled. So A is here, B is here. So we plug those into the equation. So we start with 8, and then it's 3 to the x. Assuming his owner cannot take him to the vet for the next 5 days, how many fleas will he have on the 5th day? So what do we have to plug in for x? How many fleas does poor Fido have? A lot, probably. What is it? 1,944. So on the 5th day, poor Fido has 1,944 fleas. I don't know why this owner didn't give it a flea bath or some sort of something to help it out until they could get to the vet. My dog personally takes a flea and tick medicine throughout the summer, like for the 6 months of like the warmer periods.
See, the FBI is trying to make animal abuse capital.
Huh. I can see that. It shouldn't be abuse of animals. All right, we have one more example, and then I'll get you guys your homework.
Yay.
Your mom buys you a new car for your birthday. The original value of the car is $15,000. Each year it is worth 3/5 of the original value. Write the function that models the situation. So I'm going to say f of x this time equals ab to the x. What is my starting amount? Anybody can answer. What's my starting amount? Your car started off with an initial amount of $15,000. Good. And what is my growth or decay factor? It's worth 3/5 of what it originally was. So that is your B value. So we just plug those in. So assuming you will graduate from college in 6 years, because it was your birthday that you got it, how much will your car be valued? So what do we plug in for x? How much is it worth? Huh? So after 6 years, the car is worth $699.84. Cars do depreciate quickly, but probably not that quickly over time. Also, it depends on what kind of car you buy.
Find out cool.